In this video, I'm going to go over generating component renderings. I'm going to show you the target or goal that I'm trying to achieve. I want to then show you the starting point, the fact sets that I show in most of these videos. I want to show the information that we have to work with in generating the renderings. I want to walk you through the rendering generation steps. I'll show you the final rendered component, and I will share some final thoughts on the topic of creating renderings. This is our target or our goal. Most accountants can relate to this, no problem. But in a lot of these videos, I've been showing you components or sets of facts which look like the table above. So how do you get from the component or sets of facts to something more usable by humans? What information do we have to work with? Well, we have the facts themselves that are in the component. We have the relations between the facts. We have the relations between the characteristics of the facts. We have a two-dimensional workspace, basically rows and columns and cells that make up what amounts to a page of paper. We have relation patterns, and we have known practices and preferences. So for example, some formatting, we know what people typically like, how to format grand totals, subtotals, etc. All these things are useful in generating renderings. One of the most useful are the relations between the concept characteristics, which I call an information model. Here you see a list. Got roll up, roll forward, adjustment, variance, complex computation, hierarchy. I want to focus on the roll up. That's the information model of what we're going to render in this example. Now, most people don't really understand these information models or the value that they provide very well. One final thing to keep in the back of your mind is the notion of a two-dimensional workspace. If you look at a piece of paper, it's two-dimensional, and most computer interfaces are two-dimensional. But I really want you to think about a pivot table, what you can achieve with a pivot table to basically make a two-dimensional workspace into a multi-dimensional workspace. So here you see a screenshot of pivot table interface from Excel. So while what I'm showing is two-dimensional, think about how this could be three-dimensional if you leverage a pivot table. That's basically what I'm trying to point out. So let's get started in turning our fact table into a rendering. So the first step is to identify slicers. So a slicer is any characteristic which is exactly the same for every fact within a component. Because the characteristic is the same for each fact, we can simply put the information in the upper left-hand corner and say that the information relates to every fact or set in the set of facts. We see two slicers, the reporting entity and the legal entity. Note that each of those two characteristics is the same for every fact in the set of facts or the component that we're looking at. We remove those two columns from the fact table or the component and reposition the information in the upper left-hand corner, similar to how we did this in the Excel pivot table. Next, we want to identify the columns we want to use. Generally, the concept characteristic is placed in the rows. This is not always the case, but you can think of this as a general rule. You only have two dimensions in space to work with, rows and columns. If the concept characteristic goes in the rows, we still have the columns to work with. So, what will we put into the columns? In the case of a roll up, the period will go in the columns. Showing periods side by side in the columns of a table is a common approach of the roll-up information pattern. So here we have the period characteristic highlighted. Here we set up the two columns for the period. We move the information for the value under the appropriate period column, and we delete the duplicate rows we have for each fact. And this is what we end up with. Now, the concepts are not in the order that we desire them, so we need to adjust that ordering to put the concept characteristics in the correct order. We know the relations between the concept characteristics of these facts. For example, we know our roll-up computation relation, land plus building plus furniture and fixtures plus computer equipment plus other property, plant, and equipment equals property, plant, and equipment net, the total. We can leverage this information to create the ordering of these concepts. So here, the concept characteristic is reordered in the rows per the relations that we understood about the concepts. Next, we want to make the numeric information look more presentable. We scale the numbers, showing them in thousands of dollars. We put the information about how we scale the numbers in the upper left-hand corner with the slicers because the scale information applies to all the facts in our fact set also. Next, we want to format the numbers to make them look even better. And here you see the formatted numbers with the commas added to make the numbers look more readable. Lines are added above and below the total to make that clearly identifiable as a total. And here you see the end product. The exact same set of facts which make up the component reorganized to make the information easier for humans to read. The information itself did not change. You can see that it looks virtually identical to the target or the goal. All the information in the generated rendering is explicit. For example, we do state that the information for the reporting and legal entities separately. So that's it. That's how you get from the raw fact table to the more human readable and formatted rendering. So here's some additional thoughts for you to keep in the back of your mind. So first off, computer algorithms generate the rendering, not humans. Humans aren't going to be making these transformations. Computers are. These algorithms can be adjusted for rendering preferences. You do need to add the scale factor and the units to the rendering. I left those out just to make this a little bit easier to explain. This process works for any information model, a roll-up, which we showed, a roll-forward, adjustment, variance, complex computations, etc. This same process works for any component of a financial report. Different rendering engines can establish different preferences for color, underlines, etc. You don't have to use the funky colors that I use to help make the information stand out. You can just use normal formatting information. You could render this information as Word, PDF, HTML, Excel type pivot tables, or whatever. You could use the rendering form as an input form, not just as the output generation form, but the form that you would actually use to create the information in the first place. So that's really it. We took you from the target all the way down to the completed rendering and summarized some final thoughts for you. And hopefully this gets you to understand how renderings can be created from these fact tables.